everyone. I'm Sean McCarthy, product manager from Paramount Global's Video Technology Group. The Video Technology Group is a central services team that services a lot of the internal brands that you see here. So we're responsible for building a lot of the platform products and video workflows for many of these brands. And my focus area is really on all things CDN and all things media data. So I'm happy to talk to you guys today. I guess it's time to get edgy. So no, I won't be discussing anything provocative or controversial, and unless you're still deploying all your code in AWS, I guess. We'll explore a few use cases and understand what applications are a right fit for edge deployment. And then we'll dive more deeply into two of our solutions, which leverage edge computing. The first being our CDN traffic shaping system, and then one of our responses to the growing threat of video piracy. We'll cover the solutions as a whole and the drivers for porting certain functionality to the edge. With that, let's attempt to define what we actually mean when we talk about edge compute. Here I provided a Wikipedia definition of edge compute, with the main takeaway being it's an architectural paradigm shift away from running code locally or in a core cloud data center towards exploring intermediary computing points ranging from edge devices to CDN POPs. So we're starting to really think about we're starting to think about computing as a continuum. And when we think of Fastly's computed edge offering, it falls somewhere between the on-net and far edge compute points that you see here. Today I'll cover why we decided to deploy services here and what we've learned in the process. So over the past few years, we were asked by CDN vendors and other teams, what's your edge compute use case? What's your application? How are you thinking about using edge computing? It almost actually felt like a technology in search of a problem, right? So we looked at some existing applications and said, how relevant are these to our existing business goals? One of the first use cases that came up was fraud detection. It was interesting, right? In a way, CDNs are kind of already doing this and coupling it with delivery with VPN detection and that sort of stuff. But we've seen other sort of standalone fraud detection applications decoupled from delivery. We hear a lot about edge processing being useful in IoT applications like smart city sensor data. And this is really about moving data engineering ETL concepts closer to the edge. It's a more scalable way to transform high volumes of data that are in transit. This was really interesting to us, given some data engineering challenges that we'll dive into. Manifest manipulation, content stitching, really popular video streaming use case that we'll probably talk about later in the fast breakout session. And of course, your business critical applications like porting Doom to the edge. And this really explores the potential of and the complications with adding state to your application. So anyone who gets the meme reference here, I'm still waiting for someone to port Star Fox to the edge. Regardless of your application, whether or not you choose to leverage edge compute really boils down to the need for massive speed or massive scale, right? And I wouldn't underestimate the impact of the benefits of the outsourcing the scaling challenges, right? Fastly can keep fleets of servers warm, ready to process high loads of data and save you a lot of headaches. Our use cases were driven by the need to offload client processing, so to free up browser and device resources. And although everything is stateless today, it would be interesting to explore how we can benefit from adding state to the mix in the future. And also to personalize experiences insofar as generating session-specific tokens. With that said, our edge services are not holistic solutions. They're components which enable us to achieve the latency and scale that our wider solutions demand. The first I'll discuss, our CDN traffic shaping system is known internally as Doppler, and then I'll discuss how we're approaching the problem of video piracy and how edge compute helps enable each solution. So with that, Doppler. Right, Doppler is a multifaceted platform powered by RUM data. So think of it as like an internal Sedexis or NS1 Pulsar. It involves generating client performance data, collecting it in real time, adding a layer of flexible business logic, and then making the data actionable by routing users to the most performant or cost-effective CDN. The whole idea is to prevent big rebuffering spikes like you see at the bottom by routing around CDN issues by benchmarking performance of various CDNs like you see at the top. And you'd be surprised, how much that performance fluctuates throughout the day. We constantly see, micro outages that are only impacting certain ASNs or certain geos that we're able to route around. To understand the benefits of edge compute, we'll dive a little bit deeper into how Doppler works. We have JavaScript deployed on a lot of our web properties, so think CBS.com, MTV.com, anything within the Paramount umbrella of brands. And that JavaScript is that JavaScript will compile a tasks runner, which will that JavaScript will compile a tasks runner, which will in turn request various objects from CDNs. So right now they're static 1.5 meg objects. They're representative of video stream data, but it's not an actual video stream. We open sourced a version of that tasks runner actually in conjunction with Fastly. So if anyone wants to check out the Open Insights repo, you can compile your own tasks runner in a browser. From there, the client will use the browser's resource timing API to calculate certain performance metrics. So think like time to first byte, time to last byte, throughput, availability. And then those beacons are posted to Fastly, passed through to our backend database. We're aggregating everything at the state or country and ASN level. So we generate a stack ranking of CDN performance or stack ranking of CDNs for a given user, like in New York on Comcast, for example. Then we forward those to our DNS service or our manifest generation service and steer a client consuming actual video content to the most performant CDN. So you may be thinking, okay, yeah, that's cool, but this is an edge compute. This is an edge compute talk, and we're really only using Fastly as a beacon termination endpoint and transport layer here. That's just standard CDN stuff. And you'd be right. This is how Doppler was originally designed, but we actually ran into a few challenges. So for one, we had too many test objects being downloaded, and it was costing precious bandwidth and CDN fees. So initially, every beacon required its own 1.5 meg test object. So that was 1.5 megs for availability, 1.5 for throughput, 1.5 for TTFB, et cetera. And that was for multiple host names across multiple CDNs. So that really adds up. And then there was an issue with the overall number of requests coming from the client. So just the sheer number of open connections, right? We were getting requests from our client teams and site teams to do whatever we could to just minimize the total overall number of requests, whether they were posts or downloads. There'd be a lot of time spent QAing and testing the different apps and sites. When we wanted to do like rather trivial things, we just wanted to generate a new metric, we wanted to add some data to the beacon payload, we'd have to test and QA for weeks across multiple sites to make sure nothing would break. And we lacked overall general observability on the client side into the performance of generating those beacons. So that's why we decided to rethink what the client was actually responsible for and what data it actually passes. So rather than having all of that logic exist in the client, we actually moved a lot of it server-side to a computed edge service. And now all the client is responsible for is downloading one test object, zipping up a raw data dump of the browser's resource timing API, and posting that one object to Fastly's computed edge service. So that's where we're able to actually do all of the fancy logic, right? We can uncompress the data, validate it, enrich it with the state or the geo and ASN details, and then actually compute our performance metrics. And here I'm showing the results of the redesign. Right? We were able to drastically reduce the footprint of the client from 8 requests down to 2, all while collecting denser data, which can be used to generate better, new metrics for better traffic shaping. All of our changes are now transparent to the client, leading to a better developer experience, right? We're able to push changes more quickly without fear of breaking sites or apps. Everything's 100% Terraform driven. And now we have visibility into what was once a blind spot with our edge service logging. So I'm not sure how much our sales team at Fastly will appreciate the graph on the bottom right here, but this is actually our bandwidth savings following the switch to the new client. I will qualify this with we added some sampling as well, but you could see it was like almost a 90% reduction in test object downloads. I had another slide that I didn't get in here which just shows our overall impact on rebuffering for a workflow that's using Doppler and not using Doppler. And we're seeing like in LATAM a 33% reduction in rebuffering. when a stream is actually doing decisioning powered by this platform, so it works. It's a little bit about our first use case. I'll be happy to talk about Doppler more with anyone who's interested in learning about our multi-CDN strategy. But let's move on to the second use case, right? Piracy. So I think most people in the audience understand how severe a problem piracy is. I won't spend too much time walking through the stats, but the numbers are pretty staggering, right? We all have digital assets that we want to protect or a brand reputation that we want to protect, and piracy's on the rise. We're just always trying to stay one step ahead of the game. There are many different forms of piracy, and as a company, we care about all of them. And there's lots of tools available to combat the different forms of piracy. Many of these we've been implementing for quite a while. But the two forms of piracy I want to focus on today are credential abuse and stream hijacking. And by credential abuse, it can mean a lot of different things, but I'm really talking about the problem of account sharing or users having too many simultaneous sessions. And by stream hijacking, we're talking about users accessing our actual OTT streams from third-party sites. I'll give a quick example of what this looks like in the wild and discuss why we've turned to CDN tokenization and session revocation to deal with this problem. Our CBS News stream, it's free. It's free online for anyone in the US. You just go to cbs.com and click play. But just because it's free doesn't mean we want that content appearing on third-party sites. And it does appear on sites just like this Streamlord. And you could Google any sort of pirate site and find streams like this all over the internet, right? There are even situations where these pirate sites are actually streaming our content, pointing at our CDN URLs, and then stripping out our ads and inserting their own ads. So they're able to monetize our content. We're paying for producing it, we're paying for storing it, delivering it, etc. But just because that happens doesn't necessarily mean a workflow like this would warrant full DRM. That's really expensive. And it might not even solve the problem, right? There's other partners who believe premium content with full DRM in place should be protected against this form of piracy. But there's a reason why live sports licensors actually prescribe some of the solutions we've implemented now, much similar to how Hollywood studios mandate DRM today. So we even have the full DRM sports rights workflows going through this, or having to go through this tokenization setup in the future. And that's because there are known DRM vulnerabilities. Live events are some of the most common targets, so live sports events specifically. And the high-level process that a pirate would take would be to first exploit some of the vulnerabilities on known sort of compromised client devices that we are not yet aware of. Then the pirate would catalog a stream, or actually they would first get access to our DRM keys. They're using those exploited devices. They're able to save and harvest our DRM keys, catalog our list of playback URLs, and then they can point users at their DRM service, but our CDN. So we're stuck with the cost of licensing, producing, delivering the content. All they have to do is serve some DRM keys, and basically it's a major DRM vulnerability. But if you implement CDN tokenization correctly, you can block requests at the CDN and revoke sessions from any suspected pirate sites. But it doesn't come without challenges, right? Every CDN has their own flavor of tokenization. And if you recall from the Doppler portion of the presentation, performance-based decisioning is sort of a pillar to our multi-CDN strategy. We didn't want to break midstream CDN decisioning. We wanted to be able to still load balance based on performance and not have the token be a bottleneck. So we needed a way to surface the bad actors, right? If there are sessions that are coming from or accessing our stream from third-party sites, we need to know who they are. We needed a way to revoke their access and ensure that our solution can perform at scale and not impact stream performance, so specifically video start times. We were able to address these concerns by implementing a common token schema, which Fastly and one of our other CDN vendors happen to support. There are some working groups in the industry, I know in the CTA, that are working on a common token format, but we really couldn't wait for that. We needed to implement something soon to get this to market for one of our sports rights vendors. And we repurposed our real-time logging platform from a QoE solution that was really looking at things like cache hit ratios, error rates, to a solution focused on piracy metrics. We leveraged the CDN APIs to revoke the tokens and deployed the service responsible for issuing the tokens at Fastly's edge, right? We needed that service to scale and be quick. In a standard multi-CDN workflow, our player will load a playback URL and resolve any number of CDNs. It's return the playlist and segments. It could play back the stream. CDN logs are collected in our real-time analytics tool known as Visor, and that's where we compute those QoE metrics. But looking at our security-focused workflow, things look a little different. In this workflow, the initial stream request is intercepted, forwarded to an edge service along with a JWT. The edge service is responsible for hashing a SHA-256 HMAC token, which is returned to the client. It's added to the file path of the outgoing request. And that's where we needed tokens to be generated outside of the client, and it was important that this service be highly scalable and widely distributed. So that's why we had that whole process happen at the edge. But from here, the CDNs can either allow or deny a request, server 403 if there's not a valid token, or allow a request to pass. And those same logs are sent to Visor. I would say on the CDN edge side, the real innovation there, though, is the fact we can seamlessly fail over, right, between CDNs without the token breaking. But from here, the CDN will decide what's denied, what's passed through, and Visor, which was previously used to monitor QoE, can now be used to surface bad actors. So we're looking at different vectors of piracy like request patterns per IP, per session, suspect referrers, so anything with the word pirate in the name, any site with the word pirate, unexpected user agents. And this data is used to inform which sessions will actually be revoked and blocked at this, if they weren't already blocked at the CDN edge, which tokens or session IDs should we revoke. And operators are enabled with a toolkit to kill a session by providing a token to revoke. So we have an API endpoint to both of those CDNs and can kill a session midstream. And this is just summarizing our tokenization solution, right? We worked with 2 CDN vendors to implement its standard token. We deployed an edge service to issue the tokens at scale without compromising video start times or the playback experience. We then repurposed Visor to surface the bad actors and provide an API endpoint for operators to revoke sessions for any suspected bad actor. Yeah, sounds like someone found the QR code. Yeah, so I linked a demo here for anyone interested in seeing the solution in action. I didn't have time to show it today, but we just basically show a stream on a third-party site, how we were able to surface it, revoke it, kill the session. That was a non-DRM stream, but we could have done the same with a DRM-protected stream. And I guess that brings us to our key takeaways. So when we think of edge services, we don't think of them as complete solutions, right? They're an essential component to our much wider application. It's the component that needs the real scale or speed that edge compute helps solve. I use the LOCTM, or lines of code that matter metric. The tokenization service was implemented in like 100 lines of code, so it was really simple, really quick to implement. Edge compute offloads the headache of scaling infrastructure, which is a huge one for our team. We spend a lot of time with this sort of elastic demand of our live events, scaling our data platforms, Doppler. We don't have to worry about that anymore. We offload those headaches to Fastly. And I will say there was a bit of a Rust learning curve for some of our developers. We're primarily like Python developers, but Fastly's addressed that. They're offering more language support. When we built this, it was Rust only, so there was a couple weeks of learning there. And observability, it's still new. I think edge computing observability and logging has some ways to go to be on par with some cloud logging. But we're learning and providing feedback to Fastly. So thank you, guys. you.